Hello everyone. Today we are going to see what is normal form of a matrix. So normal form of a matrix is a reduction of matrix in certain type. So what is that type? You can get that type by performing elementary row operations, column operations. We can reduce that matrix to one of the following forms. So there are types of forms of matrices. What are the types? This is IR. IR indicates that this is the identity matrix of order R by R. This is IR dash 0. So this IR dash 0 indicates that you have identity matrix with R rows, R columns, and you have additional 0 column there. This IR0 indicates that you have identity matrix of order R and you have additional 0 row here. Okay, and this matrix indicates that you have identity matrix of order R and you have additional 0 rows and 0 columns in that matrix. So any matrix can be reduced to either one of the types of these forms. Okay, so these four forms are known as normal forms of in general matrices. Okay, so now note that by using elementary row operations and elementary column operations you can reduce any matrix to any one of these forms. Okay, now what is the rank of the matrix? So you should note that the rank of the matrix is order of identity matrix in its normal form. So you have to find normal form of the matrix and then identify the order of the identity matrix in that normal form. So it will be your rank of the matrix. Now we will see one example so that you will understand what is normal form and how we can get normal form of the matrix. Okay, so this is the problem. You have to reduce this matrix to its normal form and you have to find the rank of the matrix. So we will consider A. What is your A? It is 1 1 2 3 5 3 2 7 5 12 3 3 6 9 15. So this is your matrix and you have to reduce it to normal form. That means you will get identity matrix somewhere in this matrix. So first element in this matrix is 1 and in identity matrix you can observe that in the first row you have 1 at first place. So it is okay. Now you have to make zeros here. Okay, you have 3 in the second row, you have 3 in the third row. So you can use elementary row operation. And what is that row operation? Elementary row operations are of 3 types. Okay, there are 3 types of elementary row operations. You can multiply any row by a non-zero scalar. This is one first type of elementary row operation. Second type of elementary row operation is you can interchange any 2 rows of the matrix. And third type of elementary row operation is you can add any multiple of some row to another row. Okay, that means you can add 3 times R3 in R2. You can add 2 times R3 in R1. So this is third type of elementary row operation. In case of column operations, we also use the same criteria, which is for row operation. So now you have to make 0 here, make 0 here. So in normal form, keep in mind that to make all lower diagonal entries 0, you have to use elementary row operations, and to convert upper diagonal entries to 0, you have to use column operations. So we will use R3 minus 3R1 and R2 minus 3R1. So now you will write the change. You will write the change in R3. Why? Because R3 is at first position. Similarly, you will write the change in R2 because you have R2 at your first position. So the matrix is reduced as. Now first row is as it is. You are changing R2 and R3. So first row will be as it is. 1, 1, 2, 3, 5. Second row will be 3 minus 3 times 1. R2 minus 3R1. Which row operation you have? R2 minus 3R1. So 3 minus 3 times 1. 3 minus 3 times 1, that is 3 minus 3, which is equal to 0. So this element will be 0. Now 2 minus 3 times 1. 2 minus 3 times 1 will be 2 minus 3, which is equal to minus 1. So second entry will be minus 1. Similarly, we will do for all other entries. So next entry will be 7 minus 3 times 2, that is 7 minus 6, which is equal to 1. So next entry is 1. After that, 5 minus 3 times 3, that is 5 minus 9. 5 minus 9 is minus 4. Similarly, 12 minus 5 times 3. 12 minus 5 times 3, that is 12 minus 15, which is equal to minus 3. So you will have minus 3 here. Okay. Now the next row operation is R3 minus 3R1. You will write down the change in R3. Okay. So 3 minus 3 times 1 will be 0. 3 minus 3 times 1 will be 0. 6 minus 3 times 2, that is 6 minus 6. It will be again 0. Okay. 9 minus 3 times 3, that is 9 minus 9. So 9 minus 9 will be 0. 15 minus 5 times 3. 15 minus 5 times 3, 15 minus 15, which is equal to 0. So you have entire row 0. Okay. Now the next row operation, now you have to make 0 here. Okay, sorry. You don't have to make 0 here. You have to make 1 here because you want identity matrix. Okay. So identity matrix, all diagonal entries of identity matrix are 1. So you have to make 1 here. So you will multiply the second row by minus 1. So you will get minus R2 is your next row operation. So this will give you 1 at this place. Now similarly you have to make 0 here. You can add these two rows so that minus 1 plus 1 will be 0. So you can add. Now you have to change this place. Okay. You have to change this entry. So you are making change in first row. So first row will be at first position in row operation. And the next row is R2. So you are adding R1 plus R2. You are adding second row and first row. Now first row is going to change. Why? Because you are adding R2 in first row. You are adding second row in first row. So 1 plus 0, it will be 1. 1 minus 1, 0. 2 plus 1, 3. 3 minus 4, minus 1. 5 minus 3, 2. Okay. Now minus R2, you will have 0, 1, minus 1, 4. All signs of second row, signs of all entries of second row will get changed. Okay. So 0, 0, 0, 0. Now you have to make 0 here, you have to make 0 here. You can observe that you have identity matrix of order 2. Okay, this is identity matrix of order 2. So you want 0 at every place of the next matrix. You want 0 everywhere here. Okay, so how we can get 0 here? Can you use row operation now? No, because if you use row operation, then this 0 will convert it to non-zero entry. Okay, and that we don't want. So we will not use row operation, we will use column operations now. So we have to make 0 here. If you add third column with the second column, you will get 0 here. So use C3 plus C2. Simultaneously, you can change column number 4 also. Okay, so how we can change? C4 minus 4 times C2. Okay, 4 minus 4 times 1 will give you 0. So I am subtracting 4 C2 from C4. So you can have two column operations simultaneously. Okay, first column will be as it is, second column also will be as it is. You are changing third and fourth column. Fifth column also will be as it is. So 1 minus 1, 0 plus 3, C3 plus C2. You are changing third column, you are adding second column in third column. So 3 plus 0, 3. Minus 1 plus 0, 1, 0. 0 plus 0, 0. Now fourth column is minus 1 minus 4 times 0. Okay, minus 1 minus 4 times 0, that is minus 1 minus 0. Minus 1 minus 0 is minus 1. Similarly, 4 minus 1 times, 4 minus 4 times 1. So 4 minus 4, which is equal to 0. So again you have second entry in column 4 is 0. Now what about the last entry, third entry of column 4? 0 minus 4 times 0. So it will be 0. Now you can observe that all the entries are converted to 0. Only these 4 entries are remaining entries that we have to convert to 0. So what we will use here, now to make this 0 you can use the first column. Okay, so C3 minus 3 times C1, this is the first operation. Second operation is you can add first column to the fourth column, so that 1 minus 1 will be 0. So C4 plus C1, this is the next column operation. Okay, so 1 0 0, first two columns will be as it is, 0 1 0. Okay, 3 minus 3 times 1, 3 minus 3 times 1, so it will be 0. 0 minus 3 times 0, it will be 0. 0 minus 3 times 0, it will be 0. Now minus 1 plus 1 will be 0. 0 plus 0, 0. 0 plus 0, 0. Last column will be as it is, 2 3 0. Now you have to make 0 here and you have to make 0 here. So for this entry, to make this entry 0, you can use C5 minus 2 times C1. Now simultaneously you cannot change C5 again by using one more column operation. So we have to use these two column operations separately, because you want same entries of two entries of same column to make 0. Okay, but we cannot do that, okay, at a time. So C5 minus 2 C1 will give you 1 0 0 0 1 0 0 0 0 0 0 0. 2 minus 2, 0. Second entry will be as it is. Now for this entry to be 0, we will use C5 minus 3. C5 minus 3 times C2. So this will give you, first row will be as it is, second row 0 1. Okay, 0 minus 3 times 0, so it will be 0. 3 minus 3 times 1, it will be 0. 0 minus 3 times 0, it will be 1. Now you can observe that here you have last row 0, last 3 columns 0, and you have identity matrix here. So this is of the type I2. What is the order of the identity matrix? It is 2. 2 by 2 identity matrix you have at the starting of the matrix. So order of identity matrix is 2. Hence, rank of the given matrix is 2. So in this way, we can reduce any matrix to its rank, normal form, and we can find the rank of the matrix. Okay. बंद करा. ऐका ना, प्लीज लाईक